Swayam Prabha. Digital India. Educated India.
तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Okay, let us look at a few problems that we can solve in systems of planar rigid bodies. Okay, let us start with a simple example. We have a platform, okay. I am just drawing a platform here. You would have seen something like this in a swimming pool where the person goes over here and stands, right. Now let us say we want to build a support system for this. One way that you can do is you can have something like this, and let us say this is the wall, you can pin these two like this. Okay, let us just call this as A, B, C is the platform, and let us say this D is the support. Okay, we wish to solve for forces in member or in the rigid body ABC and the rigid body BC. Also we wish to find out how much of reaction goes into the wall. Okay, that is very important because I need to know how much force the support here should be able to withstand. Alright, so let us try and solve this problem. Before starting to solve this problem, we have to make sure that we have enough unknowns and appropriate equations to solve this problem. Okay, one way to go about is to see how many degrees of freedom the body will have. Okay, usually what we do is we start with the fixed frame of reference. So as I already told you, if I put a hash, it means it is a fixed frame of reference. Now this particular body ABC will have 3 degrees of freedom. Right. Let us assume that BD is not there, so this can rotate if I put a hinge over here, which means from 3 degrees of freedom it will become 1 degree of freedom that this particular platform will have, which is just a rotation. Okay, and I wish to arrest the rotation so that this becomes stationary. The simple thing I can do is to add this particular rigid body which is pinned at B to the body ABC and pinned at D. Alright. So if I do that, this particular body BD has 3 degrees of freedom. Let us forget about ABC, look at only AB, and it is pinned at this particular point to a fixed frame. So the only degree of freedom that it has is rotating about D. Okay. So while A can rotate about ABC can rotate about BD can rotate about D. Okay, and if these two are relatively arrested from motion at B, you have 0 degrees of freedom, which means it is stationary. Okay. Now looking at this, it is better to draw the free body diagrams and understand whether we can solve this problem. Okay. As you can see here, we have 2 rigid bodies. Let us just list them down. One is ABC, the other is BD. Mind you, I am always using in the increasing order of alphabet ABC, BD, so that it is easy to understand. Alright. Now if I can draw the free body of ABC and free body of BD, then I can solve for unknowns that appear. Okay. So let us just start the exercise. Let us look at ABC. Okay. So I am going to go here, draw this particular body, this is A, this is B and this is C. The first exercise we will do is we will remove this particular body, system of rigid bodies, from the fixed frame of reference. Okay. So remove from fixed frame of reference. I am going to use FF like we have done earlier. Okay. So what happens? Let us examine. If you look at this particular point A, at this particular point it is pinned to fixed frame of reference, which means it does not allow movement in this direction and movement in the y direction, which means there are two forces that will appear. Let us say we are going to take these directions for now. Okay. If there is a convenience in using some other direction, we will change it later. Okay. So this is a reaction because of the constraint in the vertical direction at A. This will be a reaction because there is a constraint in the horizontal direction. If you look at D again, I have a constraint like this and a constraint like this, dy dx, because this point D does not move with respect to the fixed frame of reference. Alright. So looking at this, now I have removed from the fixed frame of reference. We also have a man standing on this. Let us say we have this platform which is massless or negligible weight. The person's weight W will be acting on this. Okay. There are no other forces here. Mind you, this is a system of rigid bodies that I have drawn, and this free body is complete now. Alright. So again I will repeat it. I just have to remove from the fixed frame of reference so that I get these reactions, add the external forces to the system. Okay. And one of the mistakes people do is to add the reaction that occurs on ABC due to BD. Please do not do that because this is a system that we are looking at it. Okay. Now let us examine this particular free body. The unknowns that we have that we need to solve for are Ax, Ay, dx and dy, right, which are the reactions with respect to this. Using this particular rigid body, since it is stationary, if I ask the question how many equations can I generate, the answer is I can generate 3 equations from this stationary object. That horizontal force, net horizontal force is equal to 0, net vertical force is equal to 0, and net moment about any particular point that I take is equal to 0. Okay, it makes sense, but the thing is I have only 3 equations that I can get. The reason why I am getting 3 equations is, if you look at this particular system, this system is not a system which is rigid by itself. It has its own internal degree of freedom. I will demonstrate in a moment how this appears. If you look at this carefully, for this particular rigid body, if I take this particular point and ask the question, can BD rotate relative to ABC, the answer is yes. Okay, and therefore there is one degree of freedom that I have to take care of when it comes to solving this system. Okay, and therefore it is important that I draw the free body of the other 2 rigid bodies. Okay. So I am going to now separate that. I am going to separate these 2 objects at B. Okay. How do I do this? I will fix all the other rigid bodies except the one that I am considering. Okay. So this is BD. Alright. I am looking at this particular rigid body. When I am examining the forces on this, I am going to fix, apart from the fixed frame, I am going to fix this ABC. It is not